So there's a couple of things that you should be able to do at this point without any hesitation. One is draw these diagrams to scale.
He's adding pencil to my hair.
No, it's an extra, what are they called?
Dread.
Twist.
Shit, what are they called?
No,
Hey guys,
no,
is
no,
this
dreads,
physics related, guys? Come on,
yeah,
come on.
I was trying to be culturally
guys,
appropriate.
This is not physically related. Okay. Take this out of my hair.
Okay.
Hey,
So one of the things you should be able to do without hesitation is draw this array diagram. Now, obviously, what is the first question? What does this thing hinge on? What do you have to understand before anything else?
diverging lenses.
What type of lens it is? It's a diverging lens.
Divergent.
So is it concave or convex?
Concave.
Concave. So this lens is sitting in here like this, right? Okay. So right away, what type of image can you not form? So it's placed 5 centimeters away. Is the 5 centimeters your object distance or your image distance? Okay. So you have a candle, something like that, right? So it's going to come in here, and it's going to, that first ray is going to hit that lens, and what's it going to do? It's going to diverge, right? Okay. But then it's going to try and go through the focal point that's back here. So right away, when you have a concave lens, it's the only type of image you can make. Virtual. Okay? Now, if you go through the math, and let's say you actually wanted to calculate the image distance. So you have 1 over psi plus 1 over so equals 1 over your focal length. Now, you have a focal length of 10 centimeters.
Yes, but
Is that positive or negative?
negative, you gotta be careful.
Negative. Why?
Because that's what this says.
Diverging.
Diverging lens. The light gets spread out. Okay? So therefore, your focal length is going to be a negative value. So if you want to actually calculate SI, so 1 over psi equals 1 over f minus 1 over so. So you got 1 over negative 10 minus 1 over 5. Take the inverse of all of that, you get 3.33 centimeters.
Yeah, that sounds right.
Okay?
Negative.
Negative. Right?
Of course.
So, where does that mean in terms of the focal length? Are you inside the focal length or outside the focal length?
Inside.
You're inside the focal length. Okay? Now, that's negative value. Now, here's one thing you need to kind of, the trend, you'll see, that the light is going in this direction, but what you're seeing is some of that light coming back in the opposite direction. That's another indication that you have a negative psi when it's going in the opposite direction the light is going. Okay, cool. So, if you were to calculate the magnification, how could you calculate the magnification?
Negative
Psi
psi
over ho or psi over so? Psi over so. Why?
Because this is.
What do you not know? You don't know the height. Okay, you're not giving any information about the height. Now, what's on your equation sheet is an absolute value of psi over so. Okay, that's what's on your equation sheet. I'm just telling you that's what's on your equation sheet.
Wyatt, can you mute your mic for half a second so you can speak, bro?
What's up?
The fourth time,
I'm just hearing stats.
Gavin, quit. Stop.
What did I do? Are you touching me?
It's like watching a bobber in the ocean. Stop.
I'm not even making noise.
I don't care. You're still annoying.
You're getting.
So there's a negative sign in front of that. So what does that mean in terms of the sign of your magnification?
Upright and positive.
It's upright. Okay, because the magnification is a positive number, which leads you to which answer on the first question? Question, that answer is A for number 1. And you should be able to draw this diagram, okay, to scale. Now, on the diagrams you're going to draw for this test tomorrow, what things do you think I want you to label?
Object.
Object image.
Object image.
Image. Okay? So help me. Adam,
What?
if you don't label those points, I'm not even gonna look at your diagram.
Can we do the
Why
math?
are you
Okay.
calling me out specifically? I only
Because on
labeled
that
like
lab
two
that I
of
just
them.
gave back, you didn't do that on one of them.
One of them.
You also cheated on half the lab.
Hey.
Oh!
No, removing the object
Remember with
distance
his
is
ray
not
diagrams,
cheating.
he
It's
cheated with
using your resources.
You and Nathan.
What?
So we can't use math, right? We gotta do this to scale.
Yeah.
You have to feel the art.
Feel it.
You gotta feel the
Which ones do we need
Now,
to draw?
realistically, if you do the math to check it and see if it's reasonable, that's cool.
Okay.
Okay? But in terms of like how you're actually going to determine the measurements are based upon your actual diagram.
So we should just put an approximate sign out for it. Approximately 10.
About.
Well,
Bad.
Every time I do it.
What is my scale?
Can I go back and change it?
Five.
Okay. So-
You have to do it all in 10.
I got a perfect grade
on the lab.
What do you mean?
Focal point image.
Yeah, if you just put like, if you just put object and image, I'm good with that.
Can I just put O and I?
Okay?
IO2.
Alright, so let's talk about the next one. You have a converging lens, which makes it a
Convex lens.
convex lens.
Got the English department.
Okay? Alright? Focal length 4 centimeters, 12 centimeters away.
That's why I mean that's the English department.
12 centimeters object distance, image distance.
Object.
Object distance. So, you've got this penny out here. So, you've got your three primary ray diagrams, one going through the middle. You have a focal length of 4, which puts it about here. Okay? So, you got this one coming through like this. Boink. This one going parallel. Boink. Okay? So, right away, off of a very crude sketch, what do you know about the image?
It's inverted.
It's going to be inverted.
That means
Okay.
the magnification is negative. I'm just trying to help him.
Why is it
So, in contrast to the first problem, what's going to be the sign of this focal length?
Positive.
That's going to be a positive value. So if you want to calculate the sine, you've got 1 over 4 minus 1 over 12, and you get an SI of 6 centimeters. Okay? So now when you do your magnification, that's going to be negative 6 centimeters over 12 centimeters, which gives you a magnification of
Negative
0.5.
negative 0.5, which tells you what?
Inverted and smaller.
It's inverted and smaller. Okay? So that should be, those two questions you should see old school. Now, what would happen if we take those same diagrams, but instead of lenses, we made that a concave mirror? So what do you know about, what's one difference between concave mirrors and convex mirrors?
Focal point length.
Concave.
Focal length are positive on
Concave.
concave, okay? But they're negative on
Convex mirrors.
concave lenses. So why are they positive on concave mirrors?
Because they bring the people together.
They bring it together.
The light is brought together.
Light is brought together.
Like a
Okay?
person.
Now, when in doubt, when you have a mirror and you're going to have ray diagrams involved mirrors, I promise you. What's the first one
Pizza.
that you need to draw?
Pizza.
Pizza. Okay? Draw the pizza. So, if here's your slice of pizza, let's just say, then you know it's going to come in here, hit this, flip that around, make it symmetrical. Okay? Start with that one. On any mirror diagram, draw the pizza first. Now, you also have a dashed line going up like this. So what are the only two possibilities of where that image could be.
Top right, bottom left.
Bottom left,
Top right.
top right.
Probably top right.
Inverted or
Probably top right.
upright. Those are the two options.
What is that?
If it's down here, it's inverted. If it's up there, it's upright. That's all. That's the only two options that you possibly have. Okay? You got a 50-50 shot right there.
Right
Still
here.
failing this one.
Now, if you look on, let's say for example, on this first one, let's say that focal length is way out here.
No.
If that focal length is way out here, here's your second ray diagram. Have it come in here, hit this,
Then come back.
and try and go back through that.
Oh, they're coming apart. We're falling apart.
They're coming apart,
We're falling apart.
which means what?
No way.
It's on the other side.
Because if I take this line,
From the other side.
so what are you going to have?
A virtual.
Virtual.
An upright
Virtual image.
virtual image. Okay? Now, but if I have that same thing with a concave mirror,
Closer.
but then I've got my object here and my focal length here. Again, you draw the pizza slice first.
Real image.
But now it's going to hit, it's going to go through that focal point. So now the two on the other side aren't ever going to meet. So with this one, you're going to get a real inverted image.
Wow.
Is there a Quizlet over this?
So I promise you, you're going to have one of those two images to draw
Skeleton, okay?
on a concave mirror, either outside the focal length or inside. I promise you, you're going to have one of those two. I'm just telling you, at a minimum, you're going to have one. Okay?
What's the average on this test?
So
70?
Nathan, just let him teach.
And
What does it matter?
I was just wondering.
Not relevant. What, Big Mike?
It's exactly
Can you give me,
70%.
Can
because
you
that's
give me like an estimate on like how long this test is? Like,
It's about like the other ones.
I don't know about that.
pretty much an average test.
Yeah,
I feel like it's an average. I feel like it's important.
Longer or shorter than the standard Harvard?
Longer.
Oh.
You're not getting home tomorrow.
Okay, I think it's just saying. Okay, so let's talk about that question on the back side. And again, like from this index, like this critical angle equation, I will give that to you. Okay? Don't memorize it. I will give that to you. You just have to know how to use it. Okay?
Yes.
So, here's your, and it tells you from air encounters a flat surface. Boom, here you go. So there's that angle. So right away, what's this thing going to do when it encounters the glass?
It's gonna slow down.
Slow down. Bend. More vertical or less
Yeah, with the
vertical?
normal, with the normal.
Something like this, right? Okay?
Yeah.
So N1 sine theta 1 is going to equal N2 sine theta 2, right? Cool. So, could you have total internal refraction in this scenario? No. Why?
Because it's not coming from water.
You're going from a less optically dense medium into a
Larger.
more optically dense medium. Okay? So there's no way I can make this stay within that surface. But if I shot it from the glass trying to go out to the mirror or out in the air, now if I reverse it,
Oh, then maybe.
then I could. Okay? Then I could. So if you reverse it, and let's say this is like 1, and let's say that's 1.5,
Then it can reflect.
then I can make that, I can find that angle where that stays totally within that. So let's go back for a second. I got one quick demo to show you.